Okay, still recording, good. All right, so first question, why would you even want to use a router? So everything we made up until this point has just had like a single page, right? We pretty much are just on one page, and we might like conditionally render some different components based on some state, but basically we don't go anywhere. But if you think about like a normal website you go to, normally you'll go to like the home page when you just go to the website, right? But then if you click on like about or users or contact, it takes you to an entirely different page, right? And your URL changes in the bar up top. So we haven't made any that do that yet. And to do so, we're going to need to have a router in our React application. So let's see who wants to read. Go for it.
JavaScript package that allows our UI to stay in sync with our URL. It allows us to render specific components based on which routes match or don't match the current URL path.
Does everybody know what we mean by URL? Thank you for reading, by the way. URL, just the thing in the bar at the top of the web page, tells you your location. So React Router is a JavaScript package that allows our UI to stay in sync with our URL, meaning when our URL changes, then that needs to change something that we're rendering, right? If we go to a different page, essentially a different route, we would expect that to render something different. Like if I go to mywebsite.com/users, what would you expect to see? A list of users, right? And so if we have this users route, when we match that route, when our URL matches that route, we would expect to render some component or sequence of components that shows us a list of users. But if we're not at /users, we wouldn't want that to render, right? So it's kind of like conditional rendering. It's just that conditional rendering is based on what your URL location is. So think of it that way, and it's pretty easy to understand. It does a lot more stuff for us as well, because don't think of it just as conditional rendering, but that's a real big part of it, is when I'm at certain locations, I want to render certain things. But also, just by having a router, we get a lot of additional information, which we'll talk more about in a few minutes, but we get information about what our location is, when we matched a route, what things matched, and we can get things like parameters out of that location as well. We get a history object, so we have a history of where we've been, and we can manipulate that either through links on the page or just manually moving from page to page. So how do we get started with that? Step one, you need React Router. So if you're using Yarn, it's just yarn add React Router DOM. If you're using npm install React Router DOM. Now, one thing I do want to make clear is there are a lot of React routers out there. This is probably the most popular one. That's simply called React Router. It is not made by the React team, though. So it's not officially part of React. A lot of people use it. It's very common. But like I said, I do want to make clear that it's not part of the actual official React project. It is made by the same guy that made Rebase. He's on that team. So yeah, it's good stuff, and most people use this one. So while others exist, you probably are unlikely to run across them in the wild, so better to learn this one. So once you've got it installed, one other point. Why React Router DOM, not just React Router? Because there are, again, a lot of different projects you can use React on. So if it's not a web project, if it's a React Native project, you would get a different React Router than you would for a web project. For web projects, React Router DOM. Once you have the package, then you need to use it. So when you think about putting in a router, it's just another component. And usually you would like your entire application to be inside the router, right? Because no matter where I go in the application, I want the router to know about it, so that way I can navigate different places and have a history object, a history of where I've been. It can only keep track of those things if you're inside the router. So there's a lot of different ways you can put the router into your application, but the easiest is just in your React DOM.render in that index.js file that we almost never take a look at. If you just wrap your app in the router, then that means everything that's rendered in the app is going to be enclosed in that router. So then everything is going to automatically be under the control of the router. So once we've got the package, we wrapped our app in the router, then we can start defining routes. So routes are pretty simple. You just tell it what path am I looking to match. So when I match a particular path, then what am I going to render? So the simplest one would be like that one on that top. So you don't have to put like the whole domain name. The domain name is assumed. You're just saying when it's my domain name / widgets in this example, then I want you to render a component. Which component do I want you to render? The widgets one. So pretty simple, right? Just when the path matches this, then render this component. There's also a few other options you could put in there. I've put some of the ones that you'll run into most often. We'll use this today as well. The second one has a couple extra things. Number one, it has the word exact. And the reason for the word exact is for when, kind of what it sounds like, you want an exact match of that path and nothing else. So for example, for the widgets one, if we were at the URL location mydomain.com /widgets /1234, would that still match the top one? Yeah, in this case it would. It only cares about widgets and it doesn't specify if there can be anything additional. So it's, yeah, that matches, so I'm going to render that thing. In the second case, we say we want an exact match of the path /stuff, meaning we'll only match when it is exactly /stuff. And if there's anything else in that path, then it's not going to match that. You'll notice the second one also does not have a component prop. It has a render instead. So if you just need to render a small amount of stuff, you don't have an actual separate component for that, you can still do it. You can just basically use the curly braces to say, hey, I'm going to do some JavaScript here, and just give it an anonymous function that returns some JSX. And so rather than rendering an entire component, it's just going to render, in this case, the H1 that says stuff in it. Make sense? So how do you get to different paths? React Router gives you a couple ways. So if you think about how a web page normally works, you click on a link, right, to take you to a different page. So React Router gives you components to do that. Link and navlink, and pretty easy to use. You just tell it where you want it to link to. So the to argument just takes a string that says what path you want to go to. So again, the domain name is assumed, and then it's going to be, in the case of the top one, just go to like /home. And just like an A tag, you can put text in between the opening and closing tag, and that's what will actually render on the page. So it actually renders as an A tag, but it's specifically a link so that it works within the context of the router. Navlink is very, very similar as far as the final product looks. It looks exactly the same as a link. The difference is a navlink is a little bit smarter, so it knows when it is active. So like in this case, we have a nav link that links to /party. So when I click on that, that's going to change my URL to mydomain.com /party. And then the nav link is smart enough to know, hey, the URL matches /party right now. That's what I link to. I'm going to go ahead and know that I'm the active link, and I'm going to put a class of active on my rendered link. And so that allows us to do a variety of different things. The usual application for that is if I am the active link, then I'm going to have this class of active, and I can style that differently. So just at a glance, you can see which page is active. So if you've got like a nav bar in the top, and I were to click on like about, and that takes me to the about page, then that link I could highlight differently than the other ones because that's the page that I'm on. So that's the difference between link and nav link. Other things you can do, you can use params. So what are params? They are part of the URL, but not necessarily part of, I mean, they are part of the path, but they're basically like variables that you can put into the URL. So you can basically pass information along through the URL that you can use in your program. So if we have this my page component at the top, you can see it's just a div with two components in it. One is the link that links to /about/Bob. And the link text just says about Bob. So when you click on it, you expect to see information about Bob, right? And then we have a route. So when we don't match /about /whatever, then it's not going to render. But as soon as we do match that, then it's going to render a component called user about. Now, what's the param part of this is that colon name. So anytime you see a colon in a URL, that means that part of the URL is a param. And it's just basically a placeholder variable that you can use to access whatever part of the URL matches with that. So then in my user about component, it's just a paragraph that says this is a page about props.match.params.name. So remember how I said we want our whole app to be under the control of the router because the router wants to pass information to all of its children about your location, what you matched on, the history, all that sort of stuff. So those are the three props that you get automatically for any component that's a child of a router, is the match component, the history component, and then your location, not component, objects. So this props.match, that's just provided by the router, just by the fact that we are inside of a router component. And then it has a params property. And then we said in our route path that we have a param called name, right? And so we have a name property on our params object. And so using that, we can get that Bob out of the URL and render it in the component. Does that kind of make sense? Anybody have any questions on that? So name could be anything. It doesn't have to be name. I could have called it whatever, and then said props.match.params.whatever. Like it's literally just whatever you put in there is going to be the name of the param. All right. So we said you get the match object. You also get the history object as part of props. So it'd be this props.history. It keeps track of all your navigation over time. So when you use those forward and back buttons on your browser, it keeps track of the history of where you've been. So since React is actually a single page application, you're not actually going anywhere. It's just pretending like you're going somewhere. So you have to have something to keep track of that. So as long as you are inside the router, it keeps track of its own history object and tells you where you have pretended to go this whole time. So, and then it also has these methods on it that allow you to navigate within your application without using links. So one way is to have the user click on something to take you somewhere. The other way is if you, in your program, need to essentially go to another location, make your URL change without the user clicking on something, then these methods can allow you to do that. So this is not all of the methods, but these are the most common ones. So push means that I want to push a new location onto my history, essentially meaning I'm going to go to a new location. So if I push /about onto history, then that's going to take me, that's going to change my URL to /about and take me there. Go back does what it sounds like. It's the same as clicking the back button in the browser. Go forward is the same as clicking the forward button. Go and then providing an integer can allow you to do multiple steps at one time. So like I could say go 2 and that's like hitting the forward button twice. Or I say go -3 and that's like hitting the back button 3 times. And then block. There may be certain conditions where you don't want a user to be able to go to a particular URL, and you can use block to prevent them from doing that. So that is a brief intro into React Router. Does anybody have any questions about anything related to React Router at this point? We're going to do a project with it, so it'll hopefully make a lot of sense as we start using it. But the one other thing that we are going to use in the project that a few of you have asked about is how do we get information from other places? So like pretty much other than Firebase, we've been getting information just from stuff the user puts in, right? But that's usually not the way most websites work. You have to get information from somewhere, from a server somewhere. And so the built-in way, fairly new way that's very nice to use in JavaScript is to use this fetch. Let's see. In the hat. You both have hats. Oh, there you go. You want to read that for me?
Such API provides a JavaScript interface for accessing and manipulating parts of the HTTP pipeline, such as representing also provides a global fetch method that provides an easy, logical way to fetch resources and synchronically across the network.
Thank you. So yeah, asynchronously. Does anybody know what we mean by asynchronous? Yeah.
Multiple concurrent things happen at once.
Yeah. So, well, multiple concurrent things can happen at once. Yes. So the basic idea is, so most of what we've done up to this point has been synchronous, meaning when you're thinking about your program, like if I've called a method and there's like 5 lines in that method, then the first line runs, completes, and then we move to the second line, and then that runs and completes, and we move to the third line, and that runs and completes. So all those things are sequential, and we don't move to the next one until the one before it has completed. Asynchronous is different. It means I'm going to start this thing, and we're not going to wait for that to complete. We're just going to keep going. Now, why would you want to do that? There's a lot of reasons you would want to do that. Since we're doing web projects, the main reason we want to do that is because some things take a while. Like if I'm on my phone and I have a slow connection, or you guys are on MU Guest and you have a slow connection, you don't necessarily want to wait until you get a response from the server to be able to do anything else. And if we were doing synchronous, then you would have to. You would literally not be able to click on anything until that process resolved, and then you could do something, move to the next line in the program. So what Fetch does is you tell it what URL you want to make a request to, and it says, cool, I'll do that for you, and it makes that request, and then your program keeps executing. So your user can still click on stuff, they can do whatever, and it's just saying, hey, server, give me this information, and then give it back to me when you get a chance. I'm going to keep doing my thing over here. So how do we know what to do when it comes back? You guys have seen .then a couple times now. So what that actually does when you make that request with Fetch is it returns a promise. And promise is what it sounds like. It's just basically the computer saying, hey, when I get this information back, I promise to do this next thing that you tell me to do, so that I can utilize the information that came back. So we make the request. I get a promise back. The way we use that is to say .then and give it a function to run whenever it gets back to you. Kind of make sense? Right. So it's kind of like in the olden days when you had to call with a landline and nobody could do anything like while you were on the landline, right? So if I were to call somebody else and ask them a question, they're like, oh, I don't know, I'll have to look that up. If we just stayed on the phone the whole time they were looking it up, nobody else could use the phone, right? Or if the person on the other end says, I'm going to look that up and I promise I'll get back to you when I have it, then we both hang up, we can both keep doing different things, and then they call me back, and then I can do something with the information. So the other important part of this definition is the global fetch method, meaning anywhere in my program, it's global. I can just say fetch. I don't have to import anything. It's just part of JavaScript. So you can just say fetch, and that will be globally available for you. So there's a lot of different request types. The one we'll be using is the simplest type, a GET request, meaning we're just trying to get some information. So here is what a basic one might look like. So the first argument to fetch is just the URL that you want to get information from. So what is the web address of the server that I'm trying to get information from? And then you can see we have a series of other statements. 2 of them are .then and then a .catch. So fetch says, hey, this server, I want information about your user, Bob. And then whenever that server gets back to us, we say .then, that response that we get back, parse it as JSON. We know that this server is going to return us some JSON, so we're going to go ahead and parse it. .json is, again, just something that's available to you. You don't have to import that. So that makes it into an actual JavaScript object for us. .then, so you see we can chain as many of these things as we want, and none of them are going to execute until you get that information back from the server, but then they're going to execute sequentially. So then, now that we've parsed that JSON, we know it's a user object, so we just call that argument user. And in this case, we're just going to log it to the console. The other thing we have is this .catch, which I don't believe we've not used that. in here before? So when you have this chain of promises, there could be, I mean, there's been times where I've seen like 10, 15 different things, .thens in a row, depending on how you have to process and manipulate the information that you get back. So what if something goes wrong in any of those? That would not be good. Also, you wouldn't want to have to do error handling at each one of them because that could get to be a ridiculously long thing. So the nice thing about promises is if they are all part of the same chain, if any of them fail at any point, then you can put a .catch clause in there, and that will basically short circuit at whatever point you had the error and call that .catch. So however you want to handle that error, you can call from there, whether that's retrying the same request or trying for a certain number of times, or just, in this case, putting the warning on the console. But that allows you to essentially say, this is what I want to do if we have a problem at any point in this process. Yeah. It depends. I mean, honestly, it depends on the type of request and whether your API is rate limiting, and I mean, really just what you're trying to do, honestly. 'Cause there's a lot of applications for promise. In this case, we're just talking about a simple GET request, so I would probably retry it at least a few times if you have some sort of error. Cool? All right.